Start.
Hello, my name is Pramey Jadhav. I study in class 6th and this is my math project, Procedural Generation. Generation is like generating something manually or with AI. Procedural generation is generating something based on an algorithm with a set based of instruction. Procedural generation mostly involves generating terrain for games like Minecraft. So, first let's find out how to make it. We have to use Berlin noise for this. Berlin noise is a special type of gradient noise which is made using vectors. We need to make a amount of chunks around the square of your n chunks. After that, we need to put a square amount of tiles, like 16 or 64 square tiles inside the chunk. After doing that, we need to put an influence vector on each tile inside it. Then we need to rotate it using regular snippets of the seed put into a pseudo or random number generator, and then we can finally get it like this. We have to then find the dot product of it and the single point. Using a formula 8c plus bd, where is with each one is a point that lies on a plane. After that, we can put a value to each point, and after that we find it for each of the corners of the chunk. Now we have finally made 4 maps after doing it for every chunk: upper right, upper left, lower left, lower right. After that, we merge them together using 2 functions: linear interpolation lat and smooth step. For learn, we have to find a cross section of the height map. Now this is how we do it mostly. Make ridges all across it. How much your pixel count is. Then make a line 1 by pixel count, 2 by pixel count, 3 by pixel count, all the way through. After doing that, we will finally get a curve. But still, between chunks there can be still some points. So to fix that, we will add the y value by the x value using multiply the y value by a function like sin of x, or most commonly used is 2x cubed minus 3x squared, which gives a curve plot. After that, we will get 1 octave of polynoise. To make more octaves of polynoise, we just do the same process, but with more chunks. How much more chunks is decided by a variable called locality. Locality helps us find it. If your locality is 2, then each octave will be 2 times denser. After that, we can just add them all up together. But there is a problem. If you add them all up together, you will still get white noise. So, to help us from that problem, we will use the variable called persistence. A starting octave will have persistence times something influence, and after that each preceding octave will have lower and lower. It depends on how much octaves are there. After doing that, we'll get a height map where there is good amount of detail due to the more octaves, like the 4th or the 5th octaves, and broad mountainous slopes due to the 1st and the 2nd octave that look like this. After that, we can use it in movies to make terrain and so on. But there are more real world uses. You see, conventional rocket engines have a problem that they get overheated. So cryogenic propellant is run across the them. But this wastes a good amount of cryogenic propellant. So generative AI made this rocket engine, which most humans can't even comprehend. It has a good thrust and is much better than this rocket engine, which is conventional. Also, synthetic molecular hydrogenate, I don't know how to pronounce it, is a compound that helps. You see, Alan Turing once discovered that the symmetry of embryos is broken from compounds dissolving inside them. This leads to many problems, and so he made a chart called antiscopy to find out how much he knew. There is one protein that helps restore other protein inside it, so we can reduce the effects. This protein, however, we did not know how it looks like until AlphaFold 2 or 3 generated this protein using procedural generation one time. It is used to also train AI. Thank you.